up, y'all? Professor E here once again. This time we're going to be talking about Redwood natural history. So how crazy are these trees really? What makes them so important? Well, the fact is, the tallest known redwood is 380 feet and 29 feet circumference, okay? That's a lot of mass, all right? They can also grow up to be 2,200 years old. And some redwoods have been around since the Roman Empire. That's a long time. Another reason why redwood forests are so important is that they store so much carbon! Redwoods have a unique capability of making the soil of the understory very acidic. So it minimizes the ability for other organisms, specifically plants, to grow. What we see here is a bunch of redwood sorrel and ferns. You also find tan oaks, which provide good food source for large megafauna such as bears and, chipmunks and raccoons. Another cool aspect of redwood forests is that they create their own weather. The canopy is a completely different world up there, and their needles are designed specifically to capture fog from the marine layer, the coastal redwood, and make it drip down, hitting the floor. Now, redwood roots are actually very shallow. There's no taproot going down, so they can collect and maximize their space around them. Redwoods are very specific on where they like to hang out. Here's in Big Sur, we have wet winters, and then we also have dry summers. And so they like moisture, specifically where water is. So if we look here, there's a canyon over here with some fingers going up into the hills, but most of the time, it's just dry chaparral. You won't find redwoods up high out of the canyon where water is really available. But in the summers, when the fog marine layer comes in and sweeps through and drops into the canyon, that's when those needles come into effect. #winning. Redwood trees have a hard enough time reproducing by seed. It takes 100,000 seeds to make a pound. So what they do by reproducing is they sprout. And this is a perfect example of how these sprouts will come up from the root system. Here we have these little saplings right here to like these 50-year-old trunks over here to the mama trunk in the middle. Their bark is also pretty amazing. If you take a closer look, it's very fibrous, right? It's made up of a bunch of tannins, which inhibits bugs from going in. They don't like that stuff. It can also be up to 12 inches thick, which is a perfect barrier against fires. They're very fire adaptive. Ever wondered how trees suck up all that water, especially a redwood being so tall? Water tension. So if you get water, put it in your hand or even in a cup, and you dip your finger in it and you pull out super slowly, you can see the water rise above the level. And that's what the tree is doing. The cambium is kind of flexing up as it's pulling up the water tension up through its roots and the trunk. Another superpower redwoods have is called reiteration. #fractals. So pretty much a clone of the tree can spurt from the stump even after it's cut down. Certain trees can have these things called Canopy Gardens, which duff collects in the armpit of a branch or the split of the terminal bud on a tree and create this little garden that could be very thick with duff and dirt. Seeds can fall into that and create these little canopy gardens way up there. So imagine we're 200 feet up in a tree. This is a perfect example of what a canopy garden could look like. but on a smaller scale. There was once a tree found with hundreds of redwoods growing on it, separately from the main trunk. They called it Atlas. Prime salmon habitat. Within this specialized forest, the redwoods create this opportunity for species to evolve, seek refuge, and thrive. Part of the way they connect with the landscape is that redwoods actually create the space for erosion control. With that erosion control, they create clear streams that can withstand large floods, creating habitat for salmon. And then it all being connected, as everything is, bears, megafauna come eat the salmon, drag the salmon into the forest, leave the carcass, fertilize the trees. It's all connected. Here we have the infamous banana slug, another key species in the redwood forest. Other organisms you might see are cougars, wood rats, shrews, newts, and salamanders, along with owls. Even if you cut one down, it will still keep growing. So how old are these trees really? So you could say redwoods have been around for a long time. In fact, they've been around for a very, 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 very long time. Precisely about 240 million years, around with the dinosaurs, big continent, you know, the whole shebang, okay? Going forward in evolution, they've been around in California for about 20 million years. Their current population is now along the stretch from Big Sur, just past the Oregon border. So being around for 240 million years, only 5% of old growth redwood forests still stand, and that's because of logging. One of the reasons why redwood wood is so valuable and sought out for and logged extensively was because it has the ability to not rot with moisture. Here's a perfect example of water flowing over a log and it's still pretty solid. So let's talk about our home stretch of the Big Sur Redwoods. We are standing on the most southern reach of their population. Like I mentioned before, Oregon down to here. So that's pretty cool. Redwoods weren't logged until the 1850s commercially. And that was mostly due to the gold rush in 1849 when a bunch of people came here, population started growing, and the redwood wood was very valuable for building. Big Sur didn't get heavily attacked as other areas, but we still find evidence of logging here. By 1924, half of the virgin redwoods in Big Sur were gone. So what do we see now with redwood forests? Well, what we're seeing is a lot of things. One being that we're mostly seeing only second growth forests. And then also the intensity of climate change due to, fires, sudden oak death coming in and killing the tan oaks. Examples in Santa Cruz, intense fires coming through and wiping out a lot. Also, we're witnessing evolution happen before our eyes. These small pockets of redwoods, such as the ones in Big Sur, their gene pool is smaller than those up in the north. So we're seeing a lot of things. A lot of research is going on studying these redwoods that have been around for 240 million years. #winning. But with climate change, how are they going to fare? Good questions. Some reading that I suggest, a lot of information came from, is this book, Big Sur Natural History, and The Wild Trees. Good reads.